Let's look at how to use quadratic regression to develop a quadratic model. So for example, the table we'll see shows the temperatures for a fall day in California. So here we have a series of temperatures for 8 a.m., 10 a.m., 12 p.m., 2 p.m., 4 p.m., and 6 p.m. And temperatures going from 52 degrees Fahrenheit up to 81 degrees and then back down to 76 degrees. So to find the quadratic model, we're going to use quadratic regression. So first, on a TI-84 Plus calculator, press Stat and Enter the times in L1, or List 1, using a 24-hour clock. That means 8 a.m. will stay as 8, 10 a.m. will stay as 10, 12 p.m. will stay as 12, but then 2 p.m. becomes 14, 4 p.m. becomes 16, 6 p.m. becomes 18. And we'll then enter the temperatures in List 2. So our lists should look like this. List 1 contains 8, 10, 12, 14, 16, 18. List 2 contains 52, 64, 72, 78, 81, and 76. Then we'll use quadratic regression by pressing Stat, arrowing over to the Calculate menu, and choosing number 5, Quadratic Regression. So that pulls up the quadratic regression menu. We want our X list to be L1, our Y list to be L2, frequency list will stay blank. We're going to store the regression equation in Y1, and you can do that by pressing the vars button, arrowing over to Y vars, and pressing enter and enter again, and it will put Y1 there. And this way we can graph it without having to worry about rounding or getting all the decimals right. The calculator will store the regression equation directly in Y1. Then we'll press calculate, and this is what the quadratic regression menu shows, or what the screen will show on the calculator. Now we've got our model, y equals ax squared plus bx plus c. A is negative 0.46875. B is 14.71607,143, and C is negative 36.121,42857. So if I'm rounding, I could substitute in A, B, and C and get a quadratic model that looks like this. Y equals negative 0.469x squared plus 14.716x minus 36.121. And that's our regression model. Or that's our quadratic model. Let's also look at the graph. So I can hit second y equals and go into stat plot, turn it on, choose the type so it plots the points. Our X list for our points is in list 1, our Y list is in L2. You can choose whichever mark you want. I'm going to then adjust my window so I can see everything that's graphed. So in my window, I know that my X-min I'm going to have start at 0. My X-max goes up to 20 because, or some number past 18 because that was my highest time. My Y-min, my lowest temperature, I'll start at 0. I'll make my Y-max something larger than our highest temperature, which was in the 80s, so I'll go up to 100. And then if I hit graph, I get a quadratic graph that looks like this. I see the points from my list. I see the quadratic model that we developed that contains most of these points. Let's use our model to predict the high temperature for the day. So while we're viewing the graph, we can hit second trace, go into the calculate menu, and choose number 4 for maximum. And then it'll ask us for our left bound, which we'll choose, our right bound, which you choose, and then move your blinking cursor close to your guess at the maximum, which is our vertex, and choose enter. And it tells us our maximum is found when x is equal to 15.697141, and our y, which is our highest temperature, is 79.378709. So our high temperature is approximately 79.4 degrees Fahrenheit, and this time converts to about 3:42 p.m. Let's look at one more thing. Let's use our model to predict the temperature at 11 a.m. So remember, we stored our model in Y1, and I can choose that Y1 by going again to vars, arrowing over to YVARS, choosing enter and then enter again, and the calculator will display Y1, and then in parentheses put 11 to say that we're substituting in 11, representing 11 a.m. for X. When we do that, our calculator will calculate the value for our temperature. That's our prediction. And it calculates approximately 69 degrees Fahrenheit.